Welcome to another video from McFatter Tech Musser. If you like these videos, please click subscribe.
Okay, so good morning. So today we're going to be doing Wireshark Lab on DNS. As we take a look in our documentation for this worksheet, obviously since we first downloaded it from D2L, we need to enable editing because we want to trust it. So I'll click on that gold bar, enable editing there. Now I can go ahead and I can make changes to this. First thing we got to do, right? Let's take a look here. DNS, domain name system, just as Jose just told us, it allows us to take that common name that we recognize as a website name, for example, and translate it into the address where we find it. Our system does a DNS query to our DNS server. We get a response back from that DNS server, and that's how we know where to find the address. There is an order in which we actually do these things. So we configure our local DNS server, and that's the DNS server we asked for. We're going to be clearing our cache, our DNS cache on our local computer, because if we don't do that, our computer actually looks to our local DNS cache first. So if you've already gone to a website in the past, your computer already knows where to find it. So if you do an ipconfig /flush DNS, that flushes your DNS cache, all those lookups that your computer has stored. So we're going to be doing that if we do a live lookup. So we're going to be working with our Wireshark PCAPs, but we're going to be doing a couple different things. We're going to be looking at Nslookup. That's how we can discover information. If we're working on Linux, we might use the dig command. But as we can see from the instructions, the Nslookup commands, it's available in Microsoft, in Windows, it's available in iOS and in Linux. It does have an Nslookup. We simply type Nslookup on our command line. If you only type Nslookup and press enter, it puts you into the utility. But you can type Nslookup and then the name of the website that you want to resolve, and it will do it for you. We can specify the type of record that we want to look up. We could tell it -type equals MX for mail exchange, or -type equals NS for the name server for that domain. So we can tell it to give us specific types of information. So here is an example of Nslookup, and let's do this same lookup on our computers. We're going to open command prompt. It does not have to be an admin command prompt. Regular command prompt works just fine. We're going to type in nslookup space www.nyu.edu. So nslookup www.nyu.edu and press enter. And our local DNS server at 10.252.128.2, that's one of our two configured DNS servers, the other one's .3. If it knows the answer, it simply responds back to us. And we can see that on our screen. The name of the web server, the IP address of the web server, and its alias, that www name for the website. If our local DNS server doesn't know the answer, it asks another DNS server, hey, where do I find www.nyu.edu? And it goes out and it says, hey, where's the DNS server that hosts all the .edus? And he contacts that and says, okay, hey, where do I find nyu.edu? And it tells us where to find the DNS server that hosts that. And then our local DNS server contacts that one and says, hey, what's the address for www.nyu.edu? And finally, that A record comes back to our local DNS server, which returns it to us. So it's a multi-step process, but after that's done once by our local DNS server, it knows the answer, so anybody else that wants to get to it, it already has the answer. So let's see our next example. This is responding back and saying, hey, we want to find out who the name servers, what DNS name servers does nyu.edu use. So we're going to type in nslookup space dash type equals ns space nyu.edu. So nslookup space dash type equals ns space nyu.edu. We press enter. And it returns back and shows us the name servers that they use. So we can see lots of different information. There's many, many different types of DNS records. More than we can even talk about in the context of this. But if you're interested in, there's a couple links there where you can go and you can look up how these different things work. There's lots of resources on the internet. You can also go to mxtoolbox.com, good resource. Let's see if this works. Nslookup on an IP address. Let's see, Nslookup 128.119.245.12. Oh, I typed Nslookup incorrectly. Let's see if that works. Yeah, and it returns back. That's the name of the computer science department server at University of Massachusetts, UMass. Same thing we see there. Let's take another look, or look at another example. So these are our first set of questions. We're going to run an Nslookup for www.iitb.ac.in. That's the Indian Institute of Technology in Bombay, India. So let's do that. Nslookup www.iitb.ac.in. We'll press enter. So it comes back. Looks like they used Google DNS. I'm sorry, Comcast 75.75.75.75. What is the IP address for that web server? Who can give me the answer? You can look on your screen, your Word document, your command prompt, or mine. Yes. 103.21.124.10. What's the IP address of the DNS server that provided the answer to your DNS lookup? Remember, we used ours. Fabian, what's our DNS server's IP address? A little bit louder? Exactly. That's the first DNS server listed in our order, 10.252.128.2. Another thing, if you go into command prompt and you highlight a certain amount of text and press enter, it will copy that to your clipboard. And then you can just go back to your document and hit Control V and it'll paste it in. Little shortcut there. So they ask us, did that answer come from an authoritative or a non-authoritative DNS server? Levi, did our response come from an authoritative DNS server or a non-authoritative? Look at your command prompt. What does it say? Non-authoritative answer, because our DNS server is not the one that hosts that zone. It's not authoritative for that. So I can simply just highlight non-authoritative, press enter, go back to my document and paste it in. It's non-authoritative for that. How would we go about finding the authoritative name server for it? Well, they show you the example. We did the example already. What Nslookup command or string will let us see the name server for that domain? Levi. Exactly. That says, hey, tell us what your name server is. So if I go back to that same command and get rid of the www and do a dash type equals ns and a space and press enter, it's still a non-authoritative answer because it came from our server, but those are the name servers, the authoritative name servers for that that site. And you can see in their example in the worksheet, they show the same information. It's non-authoritative because it responded back from our DNS server, but those are their name servers. So I'm going to go ahead and put that in as my answer. Now, as we talked about, when we first look something up, when we first make that DNS query, before it even reaches out to our local configured DNS server, it looks to our local cache. And it says that right there. Most hosts, i.e. your personal computer, keeps a cache of those recently performed DNS or retrieved DNS records. But if it doesn't know the answer, this is the two different ways that it looks up. It can do a lookup two different ways. It can go up to the internet. This is our local DNS server. And it starts at the very top level. It says, hey, where do I find the .in? In the case of the iitb.ac.in, says, hey, where do I find the server that hosts all the IN records? And it contacts that and says, hey, where do I find the AC domain in IN? And then it goes to that server and says, hey, where do I find iitb.ac.in? And it tells it where to find that DNS server. And that's what the steps you see here on the left-hand side. And it goes from server to server until it gets to the server that can tell what the A record for www is. A recursive query is a little different. It says, hey, where do I find this? And it goes all the way straight all the way to that server and asks for an answer back. Now, we're going to use our PCAP. So if we look at our document here, we need to open up Wireshark, and we're going to use the DNS trace file. So I'm going to open up Wireshark. Wait for it to find my interfaces. And I'm going to go up to File, Open, and I'm going to select our first DNS Wireshark trace 1-1, and we'll open that. So we've got a lot of information there, right? More information than what we want to see. We're not doing a live capture, we're using the PCAP so that we all see the same results. Our first question in this section, which is question number 5, says locate the first DNS query message resolving the name gaia.cs.umass.edu. So how do I change the view in my Wireshark to show me DNS information? Levi. In the display filter, simply type DNS and press enter. And now all we see is our DNS requests and responses, those queries to our DNS server and the responses from our DNS server. Remember, this is not us reaching out to the web server or to their name server. This is contacting our DNS server and our DNS server responding back. And in this case, it's on Comcast. 75.75.75, that's Comcast. Question number 5 says, locate the first DNS query message resolving that name. What is the packet number in the trace for the DNS query message? Jason, you on track? What's the query, the packet number for the DNS query to gaia.cs.umass.edu? 15, that's our first time, the first one. So our answer, the first part of our answer is simply 15. John, is that query message sent using UDP or TCP? UDP, that's correct. DNS runs on UDP. User datagram protocol. Now, minor, find the corresponding DNS request to that initial query. How do you know which the correct response is? Simply because it's next in order? Doesn't necessarily have to be, right? We've got it filtered by DNS. If you look to the left-hand side, see the right-hand pointing and left-hand pointing arrows? That shows you the correlation between the two packets. So what packet do we get the response? 17. That response, minor, does that come back using TCP or UDP? also UDP, User Datagram Protocol. Going back to our query, our question. Remember, a query is a question, right? Kyle, what's the destination port for the DNS query message? $53. We can see that right here, right? Destination port 53. Now, before we go too much farther, what I'd like to do is have everybody go back to Wireshark and expand the UDP, User Datagram Protocol section. I'd also like you to expand the domain name DNS section. Within that, expand the queries section. I don't think we have any questions about IP addresses in here. But you know what, just in case, let's expand the Internet Protocol version 4 information. And then we're going to get our packet information for those first two. So with that expanded, make sure your packet number 15 is selected. Go up to Edit, Copy, All Visible Items, and then we're going to paste that right before question 5. I'm going to hit Enter twice, and I'm going to go back and I'm going to do the same thing for packet number 17 and get all that detail. File, copy, all visible items, and paste that in. So I've got all of our details for packet 15, all of our details for packet 17 to support our answers that we gave in our questions, or to the questions. Anybody need more time copying that? Yes, we're on 8. And it's a good thing we expanded our IP information, right? Because right here they ask us. So, Levi, to what IP address is the DNS query message sent to? Correct. And that's Comcast DNS. If you're a Comcast subscriber, that's your DNS. So, question number 9, examine that DNS query message. How many questions, Jose, how many questions does that DNS message contain? And we can see that right in the DNS section. Questions 1. How many answers does our DNS query contain? 0. Why is it 0 answers? Because that would be you answering your own question, right? DNS queries don't contain any answers. They only contain questions. Now, moving to the response. How many questions does the DNS response contain? Jason. How many questions does the DNS response? Right, it does contain the same question. And how many answers does it contain, Jason? Right. So it says, hey, we got your question, and here is your answer. I'm going to go ahead. I'm also going to supply that answer, because right here's, we can see our query. I'm going to select that query that we got, because that's the question. And I'm going to also expand answers. And there, now we can see the IP address. The IP address is appended to the question. So I'll copy that and paste that in as my answer. Now, if we look, let's say, take a look here at this question number 11. The web page for the base file references the image object of a header graphic book 8E2 JPEG, which is on that same web server. What is the packet number in the trace for the initial HTTP GET request? Do we see that? We're not going to see it, right? Why don't we see any HTTP requests? Pretty simple. Bradley. Because our display filter is not letting us see it. So let's change that display filter to HTTP. Now, there we can see that GET request for the header graphic book 8E2 JPEG. So the question is, the initial GET request for the base file, not the JPEG, but the base file. What is the packet number for the initial GET request to their website? Anybody? Joel? 22. Second question. What is the packet number in the trace of the DNS query made to resolve that website address so that that initial HTTP request can be sent to the IP address? How would we see that? We can go back and we can look in the information that we copied. Where did we make our original query to find the answer? They're asking us, what packet number did we ask our DNS to find us that A record? You don't have to change your filter in Wireshark. You've got the answer in your worksheet as the evidence that you provided. What do you think, Miner? 15. Yeah, we've already got it. This is why we provide the evidence. The second question, or third question rather, What packet number did we get the DNS response for that A record? Kyle. No, we're looking for DNS response, not HTTP. Look in your worksheet. We copied those. We copied two packets, right? We copied our DNS query and we copied our DNS response. What was the packet number for the DNS response? Or if you want to, you can change your filter view back to DNS. If you change that view, remember our first is the query, the second is the response. What was the number? 17. Absolutely. Now, if we changed our filter in Wireshark, change it back to HTTP. If you still have it as HTTP, that's good. Who can tell me what the packet number is where we requested that header graphic book 8E2 JPEG? Levi. 205. The information's all in there. So we can see how the order of these things is playing out. So with that same thought, take a look in our HTTP. Packet number 22, the GET request for the web page, and packet number 205, the GET request for the image contained on that web page, were they sent to the same server? Do they have the same destination IP address? Yep, I see everybody nodding. Yeah. So, with that in mind, our last question in there was, what was the DNS query that gave us that second answer or answer to do that second HTTP request? Query. What was the, was it the same DNS query? Yeah. That same DNS query where we ask where to find that website, because the JPEG is also on that website, it used that same query. So packet number 15 gave us the information that we needed to be able to retrieve the image that was embedded on that web page as well. So remember, we talked about how once we've done a lookup, our local computer keeps a copy of that. It caches a copy of that DNS lookup. So looking here, when we did that second request, did we have to do another DNS request? If I switch, now remember, our request for that JPEG was on packet number 205. I'm going to switch my filter view back to DNS. Do we see a DNS query prior to 205 that would have been asking for that website again? I see people shaking their head no, and you're correct. There was not, because our computer already knew where to ask to find that, because it cached. It didn't have to reach out to the internet again and ask more questions. So, simply stated, our last discussion is, since the local computer cached the DNS lookup, it was not necessary to perform an additional lookup, period. We already knew the answer. Remember, make sure you're saving your worksheet periodically. We wouldn't want to have power interruption and have you lose your work. Everybody got the answers? Anybody need more time? Okay, good. So if we were to do another live capture, we could do this, but we're going to open up our second DNS packet capture. So I'm going to go to Wireshark. I'm going to do File, Open, and I'm going to select DNS Wireshark Trace 1-2 and open that. Here we've got a little bit different information. This was queries made to Google DNS. Now, their example, they show they did it on Comcast, but their packet capture did it on Google. So a little bit different than what their screenshot shows, but that's okay. Let's take a look. We're looking at the first query. So here again, we want to go ahead and this is right there is that standard query for the A record. You'll notice that it's doing both a IPv4 and IPv6 lookup. Yes, Bradley. One dash two. Oh, you know what? I'm on the wrong one, right? I'm going to do 2-1. There we go. Thank you. Okay, so let's go ahead. Our information is still expanded out in the details center pane, right? So let's get our first packet, the detailed information. You can do copy all visible items, or you can just select the packet header and do Control-Alt-Shift-A. We're going to paste that in ahead of our questions. And then I'm sure they're going to ask us about responses. So I'm going to select the second packet. And I'm going to do the same thing, Control-Alt-Shift-A, and paste that in. So our first set of questions ask us about the DNS query. So I'm sure many of you already know this answer. What's the destination port for the DNS query? Levi. Port 53, because that's the port on the DNS server that runs DNS, right? Second half of it, Levi, what's the source port of the DNS response? Not the same packet, the DNS response. So you select the response, and what's the source port that this response comes back from? No, that's the port that we made the request on. If you look at the first packet, our computer generated the request using port 57837 on our computer to the DNS server running on port 53. It then replied from port 53 back to our dynamic port that we had made the request on. So the destination is port 53. When the reply comes back, it comes back from 53 as well. Just depends on whether it's the query or the response. What IP address, Jose, was the DNS query sent to? Right, that would be your local DNS server, whatever it might be for your computer. And I just gave you the answer to the second half of that. Is this the IP address of your default local DNS server? Everybody. Yes. Take a look at the DNS query. We're going to examine that DNS query. What type of DNS query is it? Is it a special query? It's a standard query. Right there under flags, it tells us 0x0100, which is converting hexadecimal, standard query. So I can simply just highlight that and hit Control C and paste that in as my answer. It is a standard query. Since the query is a question, Fabian, does that query contain any answers? What's that? The query does contain answers? Do you have the packet number 19, the first one selected? Does it show any answers? I think you've got the wrong packet. Let's take a look. Yeah, you've got the wrong packet. Select 19. First one, query. You're looking for the ask question. Now, does that correspond? Does that make sense now? It's a question. It doesn't contain the answer. We're asking the question. So, no, it does not contain any answers. Taking a look at the response. So this is repeating what we did in the first exercise. This is the same types of questions. Examine the DNS response message to that query. How many questions does that DNS response, and now you want to be on packet number 20. How many questions does that DNS response message contain? Fabian. One question, right? It's responding to the question that we ask. And I can see that question right here under queries. So I'm going to even put that in. That is the question. That is the query. Jason, how many answers does the response contain? One answer to one question, right? So I'm going to highlight answers RRs. I'm going to paste that in. I'm going to go comma, space, and I'm going to provide the answer as well, which is right here. Now we're going to jump to 3-1 for our next set of questions. We're almost done, by the way. So I'm going to go into Wireshark, File, Open, and this time I promise I'm going to open the right one, 3-1. There's only 2 questions there. Or 1 question and 1 answer, 1 query, 1 response. But here again, I want to provide that information, those responses. So let's see, I'm going to actually put that down there. I'm going to use my shortcut key, Control-Alt-Shift-A, highlighting my first packet, enter, enter. I'm going to highlight my second one, Control-Alt-Shift-A, and I'll paste that in. Because this is a little bit different query. Everybody got their evidence copied in? Anybody need more time? All right, Bradley. Looking at the DNS query, to what IP address is it sent? Right, our configured DNS server. If we're asking DNS, it's always going to that DNS server. We're not asking anybody else. Is that the IP address of your local DNS server, Kyle? Yes, it sure is. You don't have to type that in. As long as it says yes. So, Kyle, in that same vein of thought, we're looking at the DNS query, the question. How many questions does that query have? 1 question. And I'm going to add that question to here. It's right here. That's the query. Query is our question. Anybody notice the difference between this question, this query, than our previous ones? Looked like you wanted to put your hand up, Levi. Oh, there, your hand's up. Now looking at the query. How is this query different than our previous ones? If you want to, scroll up to your previous answers where we provided that evidence of what the queries were. What makes this query different? They're both asking for a website, right? Bradley. It's a name server request instead of an A record request. We're asking, hey, what are your name servers? We're not asking what's the IP address of the website. That's why it says type NS. Like All of our other queries, does this query have any answers? Nope. See head shaking? No. No answers. However, if we look in our response, come on. Interesting. Figure out why this won't do this here. Indent. Okay. Okay, it wants to go here. Huh, that's weird. Huh. Why won't this thing indent? And why is it question number 19? Oh, now it goes to, wow, that's odd. Okay. Okay, so my screen's going a little haywire here. I don't know what this thing is doing. I'm just going to go with it. Okay. Examine the DNS response message. So we got to select packet number 14. Jose, how many answers does the response have? 3 answers. What does that tell you? If it's giving you 3 answers, what does that tell you? 3 records are getting returned. 3 DNS records, resource records are being returned. That's what RR stands for, by the way, resource record. And there they are. Our first one, the second one, and the third. How many, minor, how many additional resource records are returned? 3 more, right? Right here. And what are those additional resource records? The first answer says this is the name of the name server. The additional records tell us what the IP address of the name server is. So I'm just going to go ahead and I'm going to copy those in as well. So when we do the type NS lookup, it not only responds, if we do an A record, we're looking for a website. The response comes back, we say, hey, what's the IP address of this website? And it comes back and says, here's the website, it's an A record, and here's the IP address. Well, name server is a little different. It responds back and says, here is the fully qualified domain name of the name server, and additionally, here's the IP address of where you find them. Additional layers of information. So that is everything to this lab. Quick and easy. Save your document, upload it to Dropbox. At this point, I'm going to go ahead and I'm going to
end the recording and upload to my YouTube site.